So this drawing for unit standard 25705. You've got a round cylinder with a nominal bore, an outside diameter of 100 millimeters, coming in at 90 degrees to a square cylinder, square box section at 150 millimeters by 150. Some galvanized steel and 2 millimeters thick. It says up the top here, manually develop a pattern for the highlighted round pipe only. So only the round section. It's very straightforward, this drawing. I've just drawn it and lost it on the computer, so I'll start it again. So, drawing the square section up here at 150, up here at 150, back down at 150, and to complete the corner, I'll put a centre line through that, and I'm going to carry it on a wee bit further. And I'm going to have a centre line going through the other way, and I'll just extend that up another 180 millimeters just randomly. So being 100 millimeters, we have to work to the mean line. So 100 minus the 2 millimeter material thickness gives us a diameter of 98. So offsetting 49 millimeters, which is half of 98, out either side, right on the corner. And just trimming those off, that there and that there, getting rid of that. Going to put it all onto outlines. It is on outlines. This is a centre line, this is a centre line, and it's 200 millimeters 200 millimeters along the longest leg, which is in the centre of the drawing. So I'm just going to get rid of that. So 200 millimeters, I need to do a line, and I need to do it from this point here, going up here 200 millimeters, and then I want to square across 98. On top of that, I want to draw my circle. So you will use a compass. You can draw a semicircle. I have to draw a whole circle on this program, as I've said in previous videos. Get rid of those two lines there, extend the center line up to the top, and if I draw this out through to the side, that is a center line as well, that line there. So what will I do? I'll draw a line from this point right across, same on the bottom one. And I'm just going to pick a random start position here and go up here, and I'm going to offset across that 49 again. Now it shows the actual rectangular, or the square box section at 500 millimeters long. We don't need it at 500 mils to develop the pattern. We're only asked to develop the pattern for the cylinder. So all I'm going to do is extend another 20 mil either side, because that's all I need in terms of length. And I'm going to trim all this out now. Bottom line, get rid of that, and trimming it off on that line and that line. That there is a center line again. This line up the top here needs to be extended across. And what am I going to do? I'm going to run that line across to here. So this line here and this line here are projection lines, but that line from there and that line from there to there are outlines. So just trimming that off. What else do I need to trim off? From that position I trim off that, and I trim off that. So for the purposes of clarity, MT This is a plan view, looking down on it. And this is a front elevation. In New Zealand, we use third angle projection. The plan always sits over the top of the front elevation, but so this for the purposes of this drawing, we don't need to do that. I'm going to type in 8 there. You only need to draw the views that you need to actually, create a pattern. And for the purposes of this one, that's what it looks at. So technically, this side here should be up above it, but I don't want that because of the way I'm laying it out. This line down here, well, I'm going to grab that line and pull it back to that position. And I'm going to chop that line out between that point there and that point there. I'm going to draw my semicircle on top. And trim that. Get rid of that, get rid of that, get rid of that. And just for that on there. So when I do my semicircle, I have to do the full circles, as I've said repeatedly. You will just draw the arcs on here with a compass very quickly. Back the other way. And once again, I always mark them out. And just trimming those out quickly. So I get rid of that, I get rid of that, I get rid of that, I get rid of that. And then I just take those off. Take them off. Now from there I project my lines down. So down to the baseline, or the line. That doesn't look parallel, does it? Looks as if it's on an angle. So that line is not correct. Do it again. So I've got to get vertically down. That looks better. I'm only going to draw one set of lines in, of these projection lines, because I don't need them all, because it's a mirror. This side here is the same as the other side. And then what I want to do is I want to take these lines where they intersect here. They're going to go all the way across here on this side. And they are projection lines yet again. And what I'm going to do is I'm going to cheat a little. I'm going to mirror image this across. Oh, sorry, I'm going to copy it. So Control C. Actually, I need to do it a different way. I need to copy it with a base point. So these are my base point, and I'm just going to mark them on here to save a bit of time. Paste. So that's those lines. Actually, I'll take them from there as well. Copy that. Copy with a base. Yep. And paste clip. Yep. And I'm just going to take these two and mirror them to the other side. Have I typed in mirror? What have we got down the bottom? I'm just going to put that on there to there. Tell it to not dump it. Right, so looking at it side on, just a bit of a trim out here. From that point and from that point, that line disappears and that line disappears. So looking at it side on, I'm going to do a spline. You would sketch your points through here with a pencil. That's what it looks like when you look at it in the front elevation. Just trim that out. Trim all these points out. Make it look semi-professional. So side elevation, and this is our end elevation. So developing our pattern, We project horizontally across the sheet over here, so I'm going to step off 20 millimeters just for a start position. And then 98 millimeters, which was the 100 minus the 2 millimeters for the material thickness, 98 times pi. Competence want you to use 3.14 for pi, so 3.14 times 98 is 307.72. So I offset 307.72. Now you would round that up to 308 millimeters, because you're not going to be able to mark that with any degree of accuracy with a compass. Now you're going to project these lines. I'm going to do it with an extension function on this computer. Where's extension? Type in EX. I'm going to hit this line here, and I'm going to project these lines all the way across. Now I break this, I divide this length here, which was 307.72 for me, divide that by 12, and I get a length on the calculator of 25.643. So I'm offsetting those lines, 25.643, repeating. So I just run these lines across here. You can set your compass to that, scribe a little line on the end, and then project your lines down the sheet. They must hit dead on the end to get your pattern correct, so make sure they do. Projection lines. Now I need to number this. How many minutes are we? 12 minutes we're in. So numbering it MT. Well, I'm going to have my joint. I'm actually going to say where my joint is. So my joint, I'm going to draw it in as a line. So it's going to be right on the corner. So this line here, when it's rotated 90 degrees, is actually that line there, or it could be on the other side, depending on which way you rotate it, whether you rotate to the right or rotate to the left. So that's going to be my joint line, and what that means is that comes down to this height. So this line here and this line here, that's the maximum height of those lines. So I'm going to trim those out immediately. Get rid of that line and get rid of that line. So going back to my numbering issue, I'm going to pause the video and number it. So I've numbered the very ends. I've gone from the longest length on the longest side. So from this position here, this where I'm highlighting it with the crosshairs, from there down to this point here on this line is the 0 line, which is right on the side, because that's the longest point on the side there. So the 3, I've done it from 0 to 3 back down to 0 because the numbers are absolutely identical. Same on this end, but that you'll see that the numbers have changed position simply because it's been rotated towards the right. So what I need to do is number my lines across here. My shortest line is number 3, which is this one, so I'm just going to number those lines now. So I've gone and put my numbers on the drawing here. I go from 3, which is the joint line, down to 0, and then I go back up to 3, and then back down to 0 and back up to 3. So you will sketch that in with a pencil. I will draw it in with spline function. So I put my lines in. Now it's just basically a case of drawing the joint line. 3 being my shortest point, I'm going to go from 3 down to the 0, back up to the 3, down to the 0, and back up to the 3. Because it's got a curve on the side, it has to have 2 humps up in here, back up to a sharp point. So you would do it with a pencil. I'm doing it with the spline function on the computer. So SPL from 3, just scrolling in a wee bit, to 2, running off the board or off the sheet, and up to 3. Next one, starting from that same position, getting through here. So spline lays the curve in for you correctly on this program. So there's my joint line. That's all you've been asked to do. I'm just going to trim out the excess material on these that is not required. Just leaving projection lines where they would go to and leaving it at that. So that's how the pattern is drawn out. You only had to do the cylinder, as I said, roll out length of, what was it, 307 millimeters, 0.72. You would round that to 308 and divide it into 12 equal spaces and lay your pattern off. I didn't have to do all of this on this side. I simply did it for clarification. You only need from this side of the drawing leftwards. That's all you need to actually develop that pattern from a plan view. Leave it at that, thank you.